While the car is approaching you, the pitch sounds slightly above an A because the sound waves are bunched up. And while the car is driving away from you, the pitch sounds slightly below an A because the sound waves are spread out. This phenomenon is called the Doppler effect. The Doppler effect was discovered in 1842 by Christian Doppler, an Australian mathematician and physicist. This effect shifts the wavelengths of spectral features in objects that are moving toward or away from the observer. So, let's backtrack. I put this speaker in my car playing at 440 Hz. This is called the source frequency. My car was moving 50 miles per hour, or 22.352 meters per second. This is known as the source velocity. Given that the speed of sound v is roughly 343.2 meters per second, we are able to solve for the observed frequency as the car is approaching and leaving using this formula. If you plug in a negative source velocity, that indicates that the car is headed toward you, and if you plug in a positive source velocity, that indicates that the car is headed away from you. Now, let's solve it. Once you have solved the problem, you should get an observed frequency of 470.65 Hz when the car is approaching and 413.09 Hz when the car is leaving. Let's check our work. The Doppler effect doesn't only apply to sound, it also applies to light. Unfortunately, this effect can't just be seen when you look up at the night sky. Astronomers measure the Doppler effect through spectroscopy, or the study of spectra when matter interacts with or emits electromagnetic radiation. Through spectroscopy, astronomers are able to determine whether an object is blue shifting or red shifting by their absorption and emission lines. Blue shifting occurs when spectral features are switched to shorter wavelengths, and it can be observed when an object is moving towards the observer, and red shifting occurs when spectral features are switched to longer wavelengths, and it can be observed when an object is moving away from the observer. The universe is infinitely expanding, and therefore redshifting away from us as the space between galaxies is increasing. This is because the farther away galaxies are, the longer its light takes to reach us, and the redder its light appears. However, since cosmological redshift is a very slow process, it is possible that some galaxies, such as the Andromeda Galaxy, are traveling toward us faster than the expansion of the universe, and therefore blue shifting. Now that you know about the Doppler effect, I challenge you to find creative examples of this phenomenon in your day-to-day life.